Okay, so today we're going to be talking about section 6.3, which is about definite integrals and antiderivatives. Let's focus on this term, definite integral. We now know what an integral is. When we have the word definite in front of it, that just means the integral has limits from A to B. That's it. So if it's just an integral like that, that's called an indefinite integral. But if it's got limits A to B, 1 to 3, -4 to 7, and so on, that's called a definite integral. Right. So let's talk about some rules for definite integrals. First up is order of integration. So take a look at this first integral. We have the integral from B to A of f of x dx. Well, the rule is that this is equal to the negative of the integral of f of x dx from A to B. Bottom line is, look here, we have B on the bottom, A on top. Here, the limits of integration are switched, and when that happens, you have to have a negative out front. So for example, if I have the integral from 3 to 0 of, let's say, x squared dx, and now if I wanted to have the integral of x squared dx again, but this time from 0 to 3, so switching those, I have to have a negative in front. So this one says the integral from A to A of f of x dx is 0. So let's remember what an integral is. It's area, right? Which means if this is my curve and this is the point A, right? Well, this is saying I'm finding the area from A to A. Well, there is nothing to find the area of, right? So it's 0. So, like for example, if I have 2 to 2 sine x dx, that's just 0, okay? All right, next, constant multiple. If you have an integral, and inside the integral you have k, a constant, times f of x, you can pull that constant out, and it'll be k times the integral of f of x dx. So for example, suppose I have the integral from 0 to 4 of, let's say, 3x squared dx. That 3 is a constant. I can pull it out, and it'll be 3 times 0 to 4x squared dx. How do we solve these integrals actually? Like, that's going to come later on in the lesson. Okay. Sum and difference. If you have the integral of two functions added to each other, you can separate the functions into their own integrals. So you can do integral of f of x dx plus or minus integral of g of x dx. So for example, if I have the integral from -2 to 2, x squared plus 4 dx, right? Look at the x squared plus 4. I can kind of split that function right there. And so I can have the integral from -2 to 2, x squared dx, plus the integral from -2 to 2, 4 dx. Okay, next up, take a look at this. Here we have the integral from A to B f of x dx plus the integral from B to C f of x dx. Okay, so think about that. That's area, right? So we are talking about, okay, this is A, this is B, this is C. So the first one is talking about the integral or the area from A to B. The second one is talking about the area from B to C. When you add those all up, what do you get? You get the entire area from A to C f of x dx, right? So you can combine them like that. Okay, so we're going to use that right now. Let's just do an example first. Suppose I have the integral 0 to 5 f of x dx plus 5 to 8 f of x dx. Okay, you see how this and this is the same? The top of one and the bottom of the other? that means I can now combine it under one integral, and I go from the very beginning, 0, to the very end, 8. Okay, so let's do an example here. Here, I'm given a couple of integrals, all right? Let's take a look at what I'm given. 2 of the integrals involve f of x, and 2 of them involve h of x. So the first 2, the integrals go from -1 to 1, 1 to 4, and then again, -1 to 1, -1 to 5. Okay, so we're going to use these, and these are like my favorite things to do. They're like little puzzles that you can like put together, right? Okay, so first of all, I'm going to evaluate each of these integrals using only the information that I'm given in that first line above, after the word suppose. Okay, so let's do the first one. It says the integral from 4 to 1 f of x dx. Okay, so let's look at the given. Do I have anything that looks similar to that? Well, yeah, here I have the integral from 1 to 4 f of x dx, right? That's similar to this, except the bounds are switched. So I say, okay, this is equal to the negative of the integral from, this is equal to the negative of the integral from 1 to 4 f of x dx. So this is equal to the negative of, and how much is this integral 1 to 4 f of x dx? That's -2. So all this together is 2. Okay, let's move on. Let's reset this. Let's move on. The integral from, now we're asked to find the integral from -1 to 4 f of x dx. Okay, well, the integrals that I'm given up top go from -1 to 1 and then 1 to 4. So this integral is really the sum of the integral from -1 to 1 plus 1 to 4. Okay, and then this first integral up there from -1 to 1 f of x dx is 5, plus the second integral up there is -2, so together that makes +3. Okay, next one. Now I have the integral, -1 to 1, f of x plus h of x dx. Well, remember, I can split these up. So this will be -1 to 1, f of x dx, plus split it up, and I have -1 to 1, h of x dx. So I split them up into 2 separate integrals. So again, this first one up there has a value of 5, plus the second one, h of x, up there has a value of 7. Together, that's 12. Okay, next, I want to find the integral from 0 to 1 f of x dx. Okay, do I have any information? The only thing I have here is the integral from -1 to 1 f of x dx. So let's take a look at that, -1 to 1 f of x dx. So I just know that whatever the function is, the area from -1 to 1 is 5. But do I necessarily know how much the area from 0 to 1 is? I don't know. I don't know that it's exactly half. That depends on what the function looks like. So if the function looks like this, right, the area from here to here, this is not half of the other one, right? So for this one, we really don't have enough information. Okay, next one. 1 to 5, h of x dx. Okay, so let's take a look at this one for a minute. Let's see what we have here. What do we have for h of x? We have -1 to 1 is 7. Okay? You know what? Let's just draw that for a minute. Here's -1 to 1. So I know that the area from -1 to 1 is 7. And then I also know that the area from -1 to 5 is 12. Right? What am I being asked for here? I'm being asked to find the area from 1 to 5. From 1 to 5. Well, the way I do that is that green part is the difference between the red and the blue parts. So this is actually 12 minus 7, which is equal to 5. Okay, next one. Right, so what do we have here? We have integral 3f of x minus h of x. Okay, that's too much. Let's separate them. So we're going to have negative 1 to 1, 3f of x dx minus negative 1 to 1 h of x dx. Okay, we can bring that 3 out. So we get 3 negative 1 to 1 f of x dx minus negative 1 to 1 h of x dx. Now, do I have those quantities given to me? I actually do. So this is 3 times. This quantity up there is 5 minus this quantity up there is 7. Together, that makes 8. Okay, that's that. Now we're going to do something outrageous. We're actually going to go to the next chapter and learn some things from the next chapter, 7.2. Okay? And the reason why is I just don't like the way, again, the book does this. I don't think there is any reason why we should hold off on this until chapter 7. It's much more efficient if we dive into this right now. Okay, so let's go. In 7.2, the book defines the definite integral. And the definite integral is basically the family of antiderivatives of a function. Okay, what the heck is that word, antiderivative? Antiderivative is exactly what you guessed, basically the opposite of a derivative. Okay? Cool. So, in calculus, we have to get used to the fact that the antiderivative is actually the integral of f with respect to x, and it's written as this. Okay, so until now, we knew this integral to be area, right? But it is also the antiderivative. Okay, so what do we mean by that? Let's take a look at a function actually. Suppose y is equal to x cubed, okay? And I want to take the derivative y prime. What is that? That's 3x squared, right? Okay, now, that we knew from last like 2 chapters. But now, are we able to go backwards? So imagine now I gave you 3x squared. Would you be able to come up with, so I said y prime is this. Would you be able to come up with the y? What would you do? Well, you would actually do the opposite operation, right? So for example, for this one, how did we get the 3x squared? We subtracted 1 from the exponent. So here you're like, okay, I'll just add 1 to the exponent, right? And then this 3, we can divide by 3 and we come up with x cubed. And so you're like, oh yeah, of course. The original function must have been x cubed because that derivative is 3x squared. But then your friend says, no, I think the original function was x cubed plus 7. The derivative of that, think about it, is also 3x squared. And somebody else says, no, it's actually x cubed minus 4. The derivative of that is also 3x squared. Well, then how are we going to know which one of these it is? It looks like all 3 of these will work. And then you can come up with an infinite number of possibilities whose derivatives are also 3x squared, right? So then which one is the correct answer? Well, then we come up with a compromise and we say, okay, fine. Then the original function is x cubed plus some other constant c. This way, we take care of all of them. And when you take a derivative of this, you do get 3x squared. Okay? So that's kind of what we're going to talk about here. That's what this says right here. If f is any function such that the derivative is little f, then, stay with me here, the integral of little f is the antiderivative, capital F plus c. That's what you have to remember. So whenever you get the answer, you have to take plus c with it. Okay, let's actually get into how it is that we find these integrals. Okay. All right, we're going to jump right into, we already did the first two rows before. We're going to jump right into the power formulas here. Okay. So if you have an integral of something to the power of an exponent, right? What you have to do is add 1 to the exponent and divide by the new exponent and add a c. This is exactly what we were talking about. So suppose I have the integral of 3x squared dx. Okay? What I do is I have x to the power of, I add 1 to the exponent. What do I get? 3. And then I divide by that new exponent 3, but I have to add a plus c. So that becomes x cubed plus c. Okay, next rule. These are exactly like the derivatives. Remember when we were doing the derivatives, I threw all these formulas at you and I said you just have to memorize them. And then if you remember, I kept telling you, guys, you have to memorize because there's going to be a time where we're going to have to go backwards and then your head's going to spin. Okay, this is the day that we're going backwards and your head's going to spin. So let's go. Okay, so what if you have something to the power of -1? In that case, you just have to memorize and remember that this can be rewritten as 1 over u du, but its integral antiderivative is ln of u plus c. Okay, so for example, if I have the integral 1 over x dx, I just have to have it memorized and remember that it's ln of x plus c. Now, along with that, you can never take ln of a negative number, so you have to have absolute values around this one. Okay, we're going to do a lot more examples. Okay, let's do the trig formulas. Okay, all right, everyone. What is the derivative of sine? Cosine. So in the same way, the antiderivative of cosine is sine of u plus c. Okay? The antiderivative is sine of sine is negative cosine plus c. And then, all of these, the secant, and all of these, you have to, unfortunately, you just have to memorize these. But we did it for the derivatives. We're going to do it for the integrals as well. Exponential. What is the derivative of e to the x? E to the x. So the integral of e to the x is also e to the x plus c. This is the only one we're going to ignore for the time being. However, these are some new ones that I'm going to throw at you. The integral of ln of u du is u ln of u minus u plus c. Okay, do me a favor. We do not question these. There is math behind them, a lot of math, but we don't question these. We accept them as truth. Okay? So for example, if you're walking around and you see this integral, written somewhere on a billboard, something, whatever, you just go, oh my God, I know totally how to evaluate that. That's just x ln of x minus x plus c. And then watch the math parties you'll be invited to. Okay. Let's do some examples because I know your head is spinning, but we're just going to do some examples. Okay. Integral of x squared dx. First, identify what it is that you have. This is basically a power. So you have something to the power of an exponent. What you do is x to the power of exponent plus 1 over the new exponent plus c. So finally that becomes x to the power of 3 over 3 plus c. Okay, you don't believe me? Let's take a derivative of that, right? Let's just take a derivative of that. The 3 will come down. You have 3x squared over 3 plus, what's the derivative of c? It's a constant, 0. So that gives you x squared back, right? Okay. So here, integral 2 cosine x dx. Well, this is, remember the 2 comes out, right? It can come out. So this is 2 times the integral cosine x dx. So this is going to be 2 times. The integral of cosine is sine of x plus c. That's the answer. Here, the integral of e to the x. What is the opposite of the derivative, right? The antiderivative is just e to the x plus c. Okay, one thing, right? Remember what I said before is that this and this come together into the problem and they leave together. So once you take your antiderivative, you no longer need any part of those symbols. Okay. This one, where you have one term plus or minus another term, you're just going to have to do each one of them separately. So let's tackle the first one first. This is another power one, right? This is an example of a power. So you have 2x cubed, add 1 over 4, the new exponent. Okay, minus. Now we're going to do the next one. 3x to the power of 2 plus 1. That's 3. Divide by the new exponent. Next one. 8x. Exponent is 1. Add 1 divided by 2. Plus 4. Okay. What do we have here? This is actually 4 times x to the 0, right? So you add 1 to the exponent, you divide by the new exponent, and then what do we add in the end? Plus c. So finally, this is going to be x to the 4 over 2 minus x cubed plus 4x squared plus 4x plus c. All right, next one. Again, do each term separately. 3e to the x. What is the antiderivative of e to the x? E to the x. So this is 3e to the x plus, now we have a power, 2x, add 1, divide by the new exponent, plus c. I don't even have to simplify anything there. Okay. Well, I have a root, but I know what to do with roots. I rewrite them. Okay, so 6x, add 1 to the exponent, I get a 2, divide, minus x to the power of 1/2 plus 1. How much is that? 3 over 2. So this is x to the power of 3 over 2. And I'm going to divide by the new exponent plus c. Okay, but let's see what this is. 3x squared minus, now look, here we have x to the power of 3 over 2 divided by 3 over 2, right? Something divided by a fraction is the same as times the reciprocal plus c. That's going to take a little bit of getting used to, but it's going to happen so often that in like a week or two, that will become second nature. Okay, here. I'm going to add 1 to this. -2 plus 1 is -1 over -1 plus c. This is equal to negative x to the -1 plus c, right? But I can't have a negative exponent. So this is -1 over x plus c. Okay, next one here. what we have is the integral of negative sine x plus c. I'm sorry, negative sine x dx. So how are we going to do this one? Remember, the negative can come out. So I have sine x dx. So this is equal to the negative, and then the antiderivative of sine x is negative cosine x plus c. So that will be cosine x plus c, right? And if you don't believe it, what's the derivative of cosine? Negative sine. You get the integrand back. Okay, next one. Antiderivative of e to the x is e to the x plus, here I have x to the negative 2 over 3 plus 1. What will that be? 1 over 3. So I divide by 1 over 3 plus c. So this is e to the x plus, remember, I'm dividing by 1 over 3, so it'll be times the reciprocal, 3 times x to the power of 1 over 3 plus c. And then lastly, let's rewrite this as 4x to the half dx integral. I'm sorry, we're going to take the antiderivative. So now this is going to be 4 times x to the power of, add 1 to the half, half plus 1 is 3 over 2. Divide by the same new exponent. So now this is equal to 4 times the reciprocal of the bottom times x to the 3 over 2, which finally plus c. Oh, I forgot the plus c here, Miss Malikin. So this is equal to 8 over 3 x to the power of 3 over 2 plus c. And I believe this is where we will end today. Thank you very much.